example 7. And once again, it's still solve for x. And this case, we're going to do number 49, which says, ooh, this one's the longer one. All right. So 3 log 2 of x plus 1 is equal to 7. Now this one is different from our last problem because, well, first of all, we have a couple of things dangling on. We have this 1 hanging on to the equation, and we have this 3 over here causing some sort of dilation. So the first thing we have, oh, and also we have a log now. So where is our variable in this case? It's not in the exponent. It's in the argument of my log. So anytime I have something in the argument of my log, I'm going to have to use, my powers to raise it to the left, raise it to the right. Just what I said before. But before we can do any of that, we must isolate the log. Yeah. And even more than that, yeah, divide by 3. So that means we're going to end up with 3 log base 2 of x equals 6. And then if I divide it out, log base 2 of x is equal to 3. All right. So now excuse me? Oh. Thank you. Oh, that's quite all right. So now that we're at this point here, this is another place where I've seen a lot of people make mistakes, is what do we do here? Well, the thing you have to remember is there's a power rule to your, in your notes I gave you a couple of days ago. In this case, we have to raise the base of the log to what I've been calling the left power and the right power. Although technically they're both right because they're correct. So what does that mean in practice? That means I'm going to say, what is the base of my log in this case? 2. So I take 2 and I'm going to raise it to the left side, which is log base 2 of x, and that's going to be equal to, I do the same thing to the other side, 2 to the second power. Now, the important thing to know here, to understand, is that anytime I take 2, or I take the base of a log and I raise it to log of that same base, you're basically going to cancel out the word and the base of the exponent.
This is really rude, but may I go to the restroom?
Yes, go ahead.
I have a question.
Yes, ma'am.
Couldn't you have done that a lot easier and then just rewritten it?
You can, but what I'm doing here, the reason I do it this way is because as the problems get more complicated, you're right, you don't have to write out this step. You can skip this step altogether and just go right to it. But as things become more complicated, you're going to have different transformations that are going to move things around, and it's always nice to really see what's being raised to what power and how can it work out.
But if it's the same, like log 2x equals 2,
Yeah.
then you can just like...
Absolutely. Absolutely. Feel free to rewrite it as an exponential and then solve it out that way. That also works quite easily. So at this point, we end up with this x is going to pop out. So the x comes out, and I end up with x is equal to 2 to the second power, and that means that x is equal to 4 here. And these two examples, example 6 and example 7, aside from having a lot of crazy, wacky transformations, this is how you're going to solve pretty much all the problems we're doing today. And 2 raised to the second, that's a little caret. Make a little note on that.